Yes. So I left off. Just to review then, science does not have the answer for everything. We know that the world started some 13.8 billion. Before that, they thought it was 13.7. So there's an example where the scientific fact had to be modified. So a scientific fact isn't always true. Sometimes you have to change it. And then it doesn't know why. For instance, there was an extra particle left over after the first second, out of the billion of particles and antiparticles. And it used to have before before Newton, of course. Aristotle said, some 2,000 years ago, everything comes to a stop. Newton says no, nothing will come to a stop unless something stops it. There's another force that stops it. And that's his law of emotions. And he said that the reason why the moon goes around the earth and the earth goes around the sun is because of gravity. Aristotle said it was a prime mover, and then to keep things moving in the hand of God. So Newton says, no, take a cannonball and a cannon up to the top of the mountain, drop the cannonball, and it drops down like the apple did in his orchard, which he used to come up with his formula for gravity. But if you shoot the cannonball out the cannon, it'll go another kilometer or kilometer before it falls. Shoot it harder, it'll go halfway around the earth. Harder again, it'll go all the way around before it falls. Or even harder again, it'll keep going around. So it's the force of gravity and the centrifugal force that causes the moon to go around the earth. And as I mentioned last time, well, that scientific fact was proven to be not totally accurate. And Einstein said no, it's because of a warp in space-time. So here's another example where all the scientists thought, and it served the purpose for a couple hundred years, Newton's theories. And they have been supplanted then by Einstein's. But you can still use, as I say, Newton's as long as you restrict it to where it applies. So as I said, then along comes Einstein, and you have two really world visions, the Einsteinian and the quantum. Einsteinian is still kind of weird. You go around changing your space and time. And most people and think that's kind of ridiculous, but it is true nevertheless, and all evidence supports it. There's no evidence to the contrary. You can change time and space. Quantum theory, if you think Einstein's view of the world is crazy, then the quantum view is even weirder. So I say everything's based on probabilities, and you can't be certain. Now to show the weirdness, if you like, about quantum mechanics, first of all, you see that light can be a wave and also a particle. To see it's a wave, hold your two fingers up and look through them. with one eye, and you see lines. And those are called interference lines, where the waves interfere with each other. Similarly, when you throw two rocks in a pool, they both form waves, and the waves interfere with each other. So, a classic experiment then is you have two slits in a piece of cardboard, say, and you shine light through it. And when the light goes through those two slits, then what do you see on the other side, on the wall on the other side? Well, do you see two white lights, two lines? No. You see several lines. What does that indicate then? The light is a wave. When it goes through those two slits, they interfere with each other and form the waves and interference that interfere with each other. But wait, if you look at the light or measure the light before it goes through the slits, then when you get on the other side, you get two lines indicating it's a particle. Because particles would go in a straight line and form the two lines behind it. So somehow, by observation, it's changed from a wave, into a particle. And quantum field theory says everything is a wave. All particles are waves. And somehow have to be changed then into particles. Now, who is there around? How does that happen? Well, you can come up with formulas and etc. But you could say that, something happening everywhere and at all times to create matter. Something omnipresent, something omniscient, and something very smart and present everywhere. So in one sense, and I've hinted at this before, science has a void and explain a certain phenomena, i.e. how something happened, perhaps from the infinite to the finite, and several steps along the way before you came down to you. Now, I think I mentioned before how you got all your hydrogen. What about all the other molecules or atoms you have? You've got oxygen, you've got carbon, you've got phosphorus, and other atoms of other trace elements as well. Well, when you get all that hydrogen after the first second, then after the next billion years, all came together and formed bigger and bigger ball, and got a ball of hydrogen and became very hot in the center. And it squashed, packed everything together so tightly, it packed the atoms, took the space out of the atoms, which you recall was 99.999999% of the area. So when the space got squashed out, then the two protons would touch each other or fuse together. Now there is a more elaborate explanation of how this happened. And actually, they've been able to even observe some new stars in formation, so that they can actually see it almost happening in real time. But let's leave that explanation for now. It's a simple explanation. And when those protons fuse together, then they form the next. They form helium with two protons, two neutrons, and two electrons. But also there's extra energy left over. Mass or energy, same thing. And it gives off a lot of, like an explosion, like you get in a hydrogen bomb. So you've got the force of gravity trying to attract everything together, and you've got the force of fusion trying to push everything apart, explode everything. A tug of war between the two, and with that extra energy left over. And what do you got there? Well, a star is born. What's the closest star to you? Do you know its name? Well, it's the sun. So the sun is a star, and it's up there converting hydrogen to helium and giving off light and energy and warmth in the process. Now, a star which is over 10 times more massive than the sun, when it uses up all its hydrogen, it converts it on to helium, and then it fuses the helium together to form the next element in the periodic table, and so on. That's where you get your oxygen and phosphorus and carbon. But when it gets up to iron, and iron is a fairly heavy element, it's got more protons and neutrons, it doesn't give off energy, it requires extra energy. So there's no longer any force keeping the gravity at bay. And over the next few seconds, more or less, it collapses. Such force, it blows up into a supernova. Gives off more light, more energy if you like, than all the other stars in the galaxy combined, which would be some 100 or 200 billion stars. And with all that energy, it can then fuse the iron atoms together and form heavier, and most of the other heavy elements together in the periodic table to form all the chemicals or atoms. But it doesn't spew everything off into space. I mean, you've got then most of your elements created and go into space. Some that were formed in the star, and the others as a result of the supernova. But it leaves behind the atoms without any space, and so they're very heavy. They're called a neutron star. And 1 teaspoon of that would be way more than all the cars in North America. Now, a star that's over 100 times more massive than the sun, when it blows up, it leaves behind a black hole. And a black hole is so massive that even photons of light can't escape. And they now figure, recently, that the heaviest elements are formed when either two black holes collide or two neutron stars collide. So you got all that stuff going into space, and again gravity takes over and forms a second generation of a star. Our sun is third or fourth generation, and it came together 4.5 billion years ago. 10 years ago, everyone was saying. and now, sorry, they're saying 4.6 uh, billion years. But 10 years ago, everyone said it's 4.5. So again, your scientific fact is modified. Now, when it formed, along with the solar system, the light elements um, formed the sun, and everything else went around the sun. So at first, the small particles, they used electrostatic force to come together. And then when we got bigger, it was quite chaotic. So everything was bashing into each other. So things were bashing into each other, and the gravity was pulling them back in together again, forming bigger and bigger things, until we got to planets, and probably 100 planets back then. And some of the planets were even bashing into each other and pulverizing each other. The Earth was hit by another planet the size of Mars, we call it Theia, and it didn't blow up, but it knocked off a lot of the Earth's crust into space, which went around the Earth and, through gravity, formed our moon. So our moon came from the Earth. How do we know that? Well, the crust on the other side of the moon is some 27 kilometers thicker than the crust on this side. So when you go around the moon, check it out, there's one big black spot, a lava lake. Whereas you come out on this side, there's several. That's where you get the man in the moon. Or if you look from top to bottom, you see a man and a woman kissing. So it's quite romantic, isn't it? Because when the moon was forming, the Earth would have been molten because it was been bombarded by so much from outer space. And the moon would have been so close, going around, that the other side of the moon would have, and the material going around the moon as well, so the other side of the moon would be much cooler and more material would settle on that side than on this side. Also know that when astronauts brought back stones from the moon, they could only have been formed from the Earth. So that's why we know the moon came from the Earth. And it's very important because it stabilizes the Earth and allows complex life like you to thrive. But for the first billion years or so, the Earth was so hot that life could not exist. So here's another area where science cannot really definitively say how life formed. Yes, they can speculate or hypothesize that you needed these chemicals and those chemicals to come together and to form what we're made of. But that you need to have actually observe it, or take it back into your lab and actually produce it to say it's a true theory. Otherwise, it's still a hypothesis. And so far, have not been able to produce life in a lab. Frankenstein tried it, but it didn't work out that well. And he also just sewed together things that were once living and added a bit of lightning. But it didn't turn out that well. He created a monster, actually. But scientists don't talk about it much. Don't like to give the image of like in the Macbeth where they have the witches brewing up some magic potion, putting in newts and so on, working in dungeons and caves. But of course, that's just science fiction. No, they have not produced any life in Earth, in the lab. So here's another example of where science does not have the answer for everything. A definitive answer. An answer that you say is worthy of being called a theory, or a law, or a scientific fact. So back then, after the first billion years, then we would have just one-celled animals, and they just reproduce by dividing, cloning themselves into two, and so on. So we didn't really have a lot of different forms of life, different species, and so on, until sex came along. And the kind of sex we're talking about maybe 500 million years ago. Where, for instance, you get half of your genes from your biological mother and the other half from your biological father. And your genes, or your cells, they have a core as well. And that's where your deoxyribonucleic acid, DNA, comes from. And that gives you all your characteristics. Color of your hair, color of your eyes, size of your nose, etc. And your DNA is like a ladder with rungs in it. It's twisted, so it's called a double helix. And it's composed of 4 different chemicals. But when it splits down the middle, when you grow, it splits down the middle, and then the left side, another left side comes together with the right side, and that happens billions and billions of times, and usually without any errors. But if you do have one side that doesn't quite match the other, then you call that a mutation. And since the DNA gives you your physical characteristics, then that could, in your offspring at least, form a different, have different characteristics. When the plants came up onto the earth from the ocean, there were plants and animals. So there's a relationship, if you want to call it a symbiotic relationship between animals and plants. Plants take in the light from the sun, and through a process called photosynthesis, grow and give off take in carbon dioxide and give off oxygen. Animals breathe in the oxygen, and by a process using their DNA, and give off carbon dioxide. Now, the way that the animals work is that using the DNA, all your cells really are the same. It's just your DNA tells you how to, it's a blueprint or a plan on how to change your cells into the different cells that you have in your body. Your heart, your lung, and all the other cells. In some cases now, they even taken stem cells of people that can't walk, because they have a problem with their nervous system. Put the stem cells in where the damage is, and over time, then that will they will grow the undamaged nerve cells and then eventually walk. It's been done, and it's very difficult and quite new and a little bit precarious, so it's not done all that much. But nevertheless, it proves that your cells are basically all the same. So you could reproduce yourself like in Jurassic Park by taking one cell and growing yourself. So far that hasn't been done. But there was one smart-ass plant. He wanted to hog all the light. So he grew higher, became a tree. So he got a lot more sunlight on all his leaves than the lowly plants on the ground. But when he died, he couldn't rot. Most of the plants rotted, and they gave back then, when they rotted, gave back the carbon dioxide that they had used before. So at that time there would be more oxygen than there is now. The trees just fell over for a few million years and squashed down into coal. That's how we get the coal. So insects back then would have grown even bigger than they do now. Maybe a centipede would have been the size of an alligator, because they take their oxygen through tubes. And if there's more oxygen, the tubes can be longer, because the shorter ones, they absorb some of the oxygen through the tubes. So if the tubes can be longer, then they can be bigger than they are now. But there's been a few catastrophes which you got through. And a lot of life was wiped out. 5 major ones, and one 225 million years ago in Siberia, I think it was, in Russia, where there was so much volcanic activity, everything heated up, and at least some scientists think that all that coal started to burn. So it wiped out 70% of all living things at that time. 90% in the ocean and the rest on the earth. So there's a few close calls, if you want. And after that, then of course you had the age of the dinosaurs, 160 million years, where they ruled the earth. And they're cold-blooded, so they couldn't really operate at night. So mammals, of which you are one, had to stay in the underground at the daytime. Otherwise, they'd be eaten up by the dinosaurs. And they can stay underground because they're warm-blooded. They don't require the sun. So they had to come out at night then to eat. But then 65 million years ago, Jupiter, which is normally is bigger than all the other planets combined, all massive, and hence has more gravity, and hence it has more attraction. So it attracts a lot of the asteroids and meteors and meteorites and comets that could come down and hit the Earth. But this time it let through a big whopper, which went even through the Earth's atmosphere and landed in the Yucatan Peninsula in Mexico. Caused quite a stir, and started burning all the vegetation because there's so much heat from the impact. And all that debris circled the Earth and cut off the light, and hence the dinosaurs died, became extinct. So that was not so good for the dinosaurs, but better for you. Now, 10 million years ago, during that period of time, here's an example when experts can ignore evidence. Often, and they're like anyone else, come across something that is disturbing, that doesn't apply with your theory or your your thoughts. You just ignore it. Say it doesn't exist, or it's can't be true. Well, during the age of the dinosaurs, all the continents were one, called Pangea. But then they started to split apart into basically what the continents, the way they are now. I mean, they're still moving, but they're moving so slow we can't see them. A guy called, how do we know that? Well, first of all, you can look at the globe, and you can see how, for instance, South America, South America and Africa sort of fit together like pieces in a jigsaw puzzle. But that's just a hypothesis. It's not really a true theory, or it's not really a scientific fact that they were once one continent. So back in the middle of the 20th century, Wagner came up with some evidence to support that hypothesis. He measured he took some fossils from this side of the Atlantic, plant and also animal, and compared it with the fossils on the other side of the Atlantic, and found them to be identical, same species, and nowhere else on any of the other continents. So that was one piece of evidence that said that, at one time they were together. I also looked at land formations, found that they started on one side of the Atlantic and continued on the other. Even sedimentary rock, which has layers of rock laid down, it was identical on the one side of the Atlantic and matched the other, indicating there was a split right then. Fourthly, he looked at fossils in the north and found that they could only have lived in the south. So the Earth must have moved from the south to the north. So was he heralded as the greatest geologist or scientist? No. He was villainized. He was ridiculed. He was made the laughing stock of the geological and scientific community. They said, that's too ridiculous. My opinion, that is not it's correct. So rather than try to incorporate the evidence and look at the evidence, they discarded it. And science should, as I say, follow the evidence wherever it goes, not the opinions. So even experts, so-called scientific experts, can make colossal mistakes. It remained another till 1956, several decades later, until another scientist said, well, here's how it could work. The mantle, all the magma underneath the crust. Well, the crust is on plates and floating on top of this magma or mantle, and the plates move around, and you get the lava coming up, and when the plates meet, you get all your volcanic activity when the two of the plates meet, and that's called the continental drift theory. But Wagner died he was rescuing or helping out people in the snow in Greenland, and he walked off and was never seen again. He died not knowing that his theory, and you can call it a theory because there's evidence to support it, a true theory, was vindicated. So you should, just because the experts say this must be true, you should be skeptical and say, well, what's the evidence? And science, by and large, it does try to, if someone comes up with a theory, then other scientists try to prove them wrong, or to either prove them right or prove them wrong. So example then that science does not necessarily know everything, and sometimes can get it completely wrong, or can ignore evidence that should modify their way of thinking. And then at 65 million years, as I say, the big whopper came through and space and landed in the Yucatan Peninsula and wiped out the dinosaurs. But then at 10 million years ago, before South America and North America were different continents. Then at that time they came together, joined together. That changed the ocean currents and changed the climate in Africa. So before, when they couldn't support the number of trees it had before, so a lot of the land became grassland or savanna. Became crowded up in the trees, and so some of the animals decided to come down and try the luck from the trees onto the grass. And with luck would have it, they some of their DNA got bombarded maybe by cosmic rays. Some of them got through and changed so that their offspring then changed their characteristics, and those that changed so that they could better survive in the grassland went on and survived and produced offspring, and so on, and so on, and so on. So there's a lot of events that happen so that you could be here. First of all, your mother and father had to meet, so you can ask them how they met, and produce you, and you have half of their DNA, one half from each, a quarter from each of their father and mother, your grandparents. 16 from people from the last 100 years, if you have 4 generations in 100 years. Or in the last million years, 16,000. Did I get that right? Yeah. And then, of course, you had to be on the planet Earth, which is the Goldilocks of planets. It's not too far out and not too close in. Too far out, it would be too cold, and too far in would be too hot. And then in a solar system, in 100 billion or 200 billion solar systems in the Milky Way, and more we're discovering more planets, and it seems that every star does have one or more planets surrounding them. And so far, we're the only planet that we can find life on. Now, Mars, it's speculated, may have had life in the past. Who knows? They're looking at it. because of course, it's smaller, and the center of the Mars would have solidified, and they wouldn't have had the same electromagnetic shield around it to protect the life if it did ever form there. Carl Sagan, a great scientist, he has some sayings. He said, first of all, you're made up of stardust. Well, not to quibble, but all but your hydrogen is made up of stardust. And he also had the expression of the pale blue dot. When you go out in space, you see all this darkness, and all of a sudden you see this small, pale blue dot, which is the Earth, and it's blue because of all the water that surrounds it. And he was instrumental in trying to find life in the rest of the universe. SETI helped put on the golden plaques that they put on the Voyagers to explain where Earth is, and put on all the different languages of all the different cultures on Earth, in case some civilization would intercept the Voyager and find that plaque in the future to prove that we existed. And he produced the series called Cosmos, which is very popular. And there's a new series by Neil deGrasse Tyson, who was influenced by Carl Sagan, a new series of Cosmos, which updates it and explains a lot of different scientific phenomena. But then you're brought on the Milky Way, which is one of, again, 100 billion or 200 billion other galaxies. And you have, excuse me, and you are made up of those, except your hydrogen, carbon atoms and oxygen atoms are produced between 13 billion years ago and 4.6 billion years ago. So you could have a carbon atom in one finger that's 12 billion years old, and a carbon atom in another that is 6 billion years old. And then you had to survive, of course, the 1 in a billion chances that you got your mass or your particles. And then you got all your, in the first second, you got all your forces. Force of gravity, which keeps you on the ground. An electromagnetic force, which keeps you from falling through. Now, and I said before, the reason why you don't fall through with all that is because you have all that space. It's because the electrons in the atoms in you and the electrons in the on the floor are both negatively charged and repel, and therefore the electromagnetic force keeps you from falling through the floor or walking through a wall or pushing your finger through your arm. Then you get the strong force, which keeps your all your molecules together and your atoms together. It stops you from flying apart. And again, your weak force that keeps you saves all the harmful solar cosmic radiation and gives you your atmosphere, and which stops a lot of the harmful debris coming down and killing you. So, you are a result of all those different steps, and if one of those steps didn't happen, you wouldn't be here. And science cannot really understand exactly why all those steps happen. For instance, if the force of gravity was not the way it is, if it was any little stronger, it would have all the hydrogen that was produced would have been attracted back into a big crunch, and it wouldn't have gone on to produce the stars. And if it was any weaker, again, it wouldn't be strong enough to bring all the hydrogen together and form the stars. And now there's another constant as well that they can't understand. It's called the cosmological constant. Now, when Hubble discovered that all the stars were receding away, and that by figuring how fast it was receding away, you go back in time and figure it was 13.8 billion years ago. Well, Einstein, when in his general theory of relativity, had a constant called lambda, the cosmological constant, and that would have let the explain why the universe can expand or contract. He took it out because he, like everybody else, thought that the universe doesn't expand or doesn't contract. It just is, which he said was the biggest mistake in his career. The biggest mistake is that he took it out and should have left it in, because it does explain now how the universe expands. So they looked at it and said, well, let's find out when it's going to stop. It's going to slow down, go to cool down, maybe reverse itself, go back into a big crunch. So they looked at it, and to their surprise, they found, no, it's not slowing down, it's accelerating. So why is that happening? There must be another force or some more other energy that's counteracting gravity, because gravity is trying to pull everything back, attract everything back. But if it's expanding, there must be some other energy that is winning the battle over gravity. Don't know what it is, so they call it dark energy. Not only that, they think it needs to. It's 75% of the universe. They hypothesize or speculate that space itself is not empty. It's full of virtual particles and antiparticles, which come together and produce the energy. Now, it's hard to take that back in the lab and test it out, because being virtual is really not real. So it's still a hypothesis, but they have to have some explanation why the universe is expanding. Not only that, they look at the amount of when you get the universe expanding, you get more space, you get more energy, whereas the amount of matter stays the same, and therefore the energy is winning over gravity, because the normal matter causes the gravity. But not only that, they figure they need more gravity than can be accounted for with all the matter. Need 4 times as much matter. And they don't know what it is. Can't see it. It doesn't react to the electromagnetic radiation, vision, or X-rays, or anything. But to explain some phenomena, they need to have more matter or more. So they call it dark matter, because they can't see what it is, and it's not composed of the regular, quarks and atoms and molecules and so on. Again, they call it WIMPs. They're trying to find it, but they can't find it. They think it may be WIMPs, weakly interactive particles. Weakly interactive massive particles. And they're doing experiments in space and also at CERN. but they can't. So far as that, they have not found anything. So it's a complete mystery, and they're in the dark. So science is in the dark for literally 95% of what's going on. So when you say science knows everything and can explain everything, well, no, only 5%. And in that 5%, it has two different theories. So can they both be right at the fundamental level? Well, they both have evidence to support them, but how can you say that the science can understand how the world works if we have two different explanations? Not only that, when they look at Einstein's cosmological constant, when they figure out what it is, they measure it, and they theorize what it should be based on all their scientific facts, scientific theories. They're out by 10 to the 120th. That's a colossal difference between what they theorize and what is actual. Now, they may have some speculation of why that happens, but they really can't explain it. So it really points to, and here's one vision, is that there's all these constants so on have been set by someone who's creating the universe, so designed. Because everything seems to be exactly the way it has to be in order for you to be here. So, you can say then, science cannot has on the fundamental questions does not have the answers. So is there then the spiritual world? Is there something that is over and above the scientific or physical world that's responsible for you being here? In all those events, is there someone that is that's overlooking, changing all your waves into particles? So whether you often hear people say, only God knows if something happens that you can't understand. God only knows. Or if something happens that's fortuitous, or doesn't happen, that would be detrimental. You say, thank God that happens, or thank God that didn't happen. So you could say, thank God I've got a force of gravity. Keeps me on the earth. Stops the Chinese from falling off. Thanks God the electromagnetic force is greater than gravity. Otherwise I'd fall down through the earth like everybody else. Maybe fall into a black hole or singularity. And God only knows what that is. Thank God the strong force is greater than the electromagnetic force. And the electromagnetic force keeps me 1 angstrom units away from everything else. Otherwise I'd fly apart. And thank God that there's an extra particle left over out of a billion, so that I can have some mass and exist. And thank God all the other millions and millions of events happen, which would otherwise mean if they didn't happen, I wouldn't be here. So whether you think that all these events were accidents and random accidents, fortuitous as they may be, or whether you think that you can take it literally, thank God, nevertheless, you are a miracle. It's miraculous that you're here. Therefore, why are you here? You are a miracle. And providing you let science deal with the physical and religion deal with the spiritual, then the two complement each other rather than conflict with each other. End of story.